Humans have always looked up at the stars and wondered, what is out there? How far does it go? Could we ever travel there? The answer to that last question, for centuries, seemed like a resounding no. But then came the invention that changed everything, the rocket. Early rockets, like fireworks, were simple. They used burning fuel to create hot gas. This gas expanded and shot out one end, pushing the rocket in the opposite direction. Over time, rockets became more complex. Scientists and engineers made them bigger, more powerful, and capable of carrying heavy loads. These advancements paved the way for space exploration. In 1957, the Soviet Union launched Sputnik, the first artificial satellite, into orbit. 4 years later, Yuri Gagarin became the first human in space. And in 1969, American astronauts Neil Armstrong and Buzz Aldrin walked on the moon, a feat made possible by the mighty Saturn V rocket. The history of rocketry is a testament to human ingenuity. It showcases our drive to explore, to push boundaries, and to venture beyond the familiar confines of Earth. But how do these incredible machines actually work? Let's delve into the fascinating world of rocket science. Building a rocket is like assembling a giant complex puzzle. Each piece has a specific job and they must all work together perfectly. Let's break down the main components of a rocket. At the heart of it all is the engine. Rocket engines burn fuel and oxidizer in a combustion chamber. This creates a powerful stream of hot gas that blasts out of the nozzle, propelling the rocket forward. This is based on a scientific law called Newton's third law of motion. For every action, there is an equal and opposite reaction. To power these engines, rockets need a lot of fuel. This is stored in large tanks, often taking up most of the rocket's body. The type of fuel varies, but it's usually a highly combustible liquid like liquid hydrogen or kerosene. Along with fuel, rockets carry an oxidizer like liquid oxygen, which allows the fuel to burn efficiently even in the vacuum of space. On top of the rocket is the payload. This is the part that carries the important stuff: satellites, telescopes, astronauts, or even scientific instruments heading for other planets. And finally, no rocket is complete without its guidance system, a computer brain that steers the rocket on its designated path. Imagine standing on a skateboard and throwing a heavy ball forward. What happens? You roll backward. This is essentially how rockets work, just on a much grander scale. By expelling hot gas at incredible speed, rockets generate enough thrust to overcome Earth's gravity and soar into space. To reach space, rockets need to achieve escape velocity, which is about 25,000 miles per hour. To do this, they often use multiple stages. Think of it like a relay race. The first stage, usually the largest and most powerful, lifts the rocket off